Welcome to the AI Research Roundup. I'm Alex, and today we're looking at a paper from the Hugging Face trending list, published on the 23rd of June 2025, T 14 hours 40 minutes and 49 seconds .00000. This paper, published just 2 days ago, introduces a new interactive world model that won in human evaluations over 96% of the time for overall quality. The paper is titled Matrix Game, Interactive World Foundation Model, and as we'll see, the results really show a new level of control for this kind of world generation. The authors built this model by creating a massive new dataset with thousands of hours of gameplay, and they also developed a new benchmark to properly measure performance. Also, the authors shared their project on GitHub. You'll find everything you need to get started there, including the model code, their new game world benchmark for evaluation, and scripts to run inference yourself. They've really put the whole package out there for the community to dig into. And on Hugging Face, you'll find the 17 billion parameter matrix game model with quick start guides to download and generate your own interactive game worlds. So let's take a look at what this actually looks like in practice. This first figure shows a series of generated video clips from the matrix game model across a ton of different Minecraft environments, from deserts and beaches to more complex icy and mushroom biomes. You can see how the world stays consistent as the viewpoint moves. The model itself is a type of latent diffusion model, which means it generates these complex scenes in a compressed, hidden space for efficiency. And it does this auto-regressively, using the last frame to help create the next one. So to train a model like this, you need an incredible amount of high-quality data. This diagram shows exactly how the authors created their dataset. They started with a massive 6,000 hours of raw Minecraft video clips. Then, they ran this data through a whole series of filters. First for video and aesthetic quality, which cut it down to 2,700 hours. After that, more filters removed things like menus, subtitles, and jerky camera movements, leaving them with a final clean dataset of 870 hours. This rigorous filtering process is key to the model's performance. Alright, so with that high quality data, how does the model actually work? This next diagram shows the interactive image to world paradigm. On the left, it takes in previous video frames and a reference image. These are compressed into an efficient, hidden representation, what's called a latent space. The core of the model is a diffusion transformer. This component takes the compressed information, adds user commands and some initial noise, then generates the next part of the scene. Finally, a decoder turns this hidden data back into the video we see, creating a consistent and controllable world. Okay, so we have this powerful model, but how do we actually measure if it's doing a good job? Well, to solve that, the authors created a whole new evaluation benchmark called the Game World Score. This figure breaks it down. The score is based on 4 main pillars. Visual quality, which covers aesthetics and image clarity. Temporal quality, which looks at motion smoothness and consistency over time. Action controllability, measuring how well the world responds to keyboard and mouse inputs. And finally, physical rule understanding. This detailed benchmark is what allows for a truly objective comparison. This table then puts that game world score to the test, comparing the author's model against 2 others, Oasis and Mineworld, and the results are pretty clear. Across almost every metric, their model comes out on top. You can see the most dramatic improvements in action controllability, with keyboard and mouse accuracy both hitting a score of 0.95. It also scores much higher in physical understanding, especially in keeping objects consistent. These numbers show the model isn't just making pretty videos. It's creating a world that is genuinely interactive and follows consistent rules. So, the automated scores are impressive, but the real test is what humans think. This next chart shows results from a double-blind human evaluation, where people rated video clips without knowing which model made them, and the results are just a landslide. For overall quality, their model was preferred over 96% of the time. For controllability, it was nearly 94%. This confirms that the high scores from the benchmark really do translate into a more perceptually realistic and controllable experience for a human user, which is a huge validation of their approach. So what's the big picture here? Well, the work on Matrix Game really tackles 3 huge challenges at once. They built a massive, high-quality dataset, created a powerful interactive model, and developed a comprehensive benchmark to measure success. A key part of their model is its autoregressive generation. This is a strategy where the model creates the future one step at a time, using its own previous output as the input for the next step. This holistic approach is what allows for a new level of interactive and physically consistent world generation. That's all for this week's AI Research Roundup. Thanks for tuning in.